Of course, there's advantages and disadvantages to selecting either a polyclonal or a monoclonal antibody. Polyclonal antibodies are cheaper to produce compared to monoclonal antibodies. I suppose the characteristic is the antibodies and polyclonal antibodies, the antibodies are from different B cells, whereas the monoclonal, as we spoke previously, is a single antibody from a single B cell clone. So the polyclonal is multiple different antibodies, whereas the monoclonal is a single homogeneous antibody. The polyclonal antibody will bind to different multiple sites on one antigen, whereas the monoclonal antibody will bind to a single site on the antigen. And the advantages to that is that you're able to target a specific region on the antigen. Now, disadvantage with polyclonal is you'll get batch-to-batch variation, which creates problems when you get to the clinical setting. Whereas the monoclonal has very low batch-to-batch variation, making it very much useful for clinical applications in terms of precision and accuracy and reliability. Which leads us to the conclusion that polyclonal isn't great for clinical diagnostics, whereas the monoclonal is very useful for clinical diagnostics. I suppose the advantage of the polyclonal is it's very tolerant of slight changes to the protein structure, such as phosphorylation or maybe some form of denaturation or modification of the protein, because there are multiple sites that the polyclonal antibodies can target. Then if you have 4 sites and 1 site gets modified, at least you still have the 3 other sites that will bond normally. The problem, of course, with a monoclonal antibody is that any slight change to the epitope or region that the antibody is trying to bind to will actually interfere with the ability of the antibody to work. Okay, and this is another sort of summary table of reiterating, I suppose, what we've said in the previous slide, in terms of the advantages and disadvantages. Okay, and this is a nice diagram that's supposed to highlight how a monoclonal antibody preparation would like versus a polyclonal preparation. As you can see, it's a single antibody for the monoclonal preparation, whereas the polyclonal has 4 different antibodies targeting 4 different regions of the antigen. So, bringing all this together, when you produce an antibody that's specific towards a target, it can then be used in a whole range of different ways. It can be used for ELISAs, which is widely used. It can be used for a Western blot. It can also be used for immunohistochemistry, immunocytochemistry. It can be used to quantify targets in flow cytometry. It can also be used for immunoprecipitation. And of course, then you have something separate, luciferase-based quantification of proteins is also another approach that can be used. But that doesn't involve immunobioassays. Okay, folks, but what predominantly I'm going to focus on today is the use of ELISAs to quantify biomarkers of interest. And then when we get to the Luminex-based system, it's almost like an adaptation of flow cytometry in relation to quantification of biomarkers of interest. So in terms of the immunodiagnostic section now that we're going to focus on, I'm going to give an introduction to immuno-based detection methods. As I said, primarily focusing on the ELISA. There is a link to an overview of flow cytometry for those of you who are interested. It's a previous recording that I've recorded. So it's there for you if you want to view it. But then we're going to focus on the multiplex-based systems. So whilst we'll give the basics of the ELISA, we'll then go on to talk about a specific type of ELISA, electrochemiluminescent-based multiplex ELISAs that are produced by MSD, which is an American-based company. But then we'll go on to talk about B-based multiplex flow cytometry, which is a fluidic-based immuno-based bioassay system. And we'll talk a little bit more about this. These two platforms, to a certain degree, are in their infancy. They have a range of biomarker assays that are useful for research purposes, but that aren't clinically validated. Of course, then they also have other biomarkers that they haven't through the processes of clinically validating.